Hi friends, to many of us problems related to Van 5 factor remains problematic. So this video will try to eliminate that. We are going to work out some hand-picked 5 problems. Okay. Before that, let us understand what is I. I is nothing but the ratio between observed colligative property and calculated colligative property. It can also be expressed as the ratio between calculated molar mass to the observed molar mass. And I is also nothing but the total number of moles of particles after association or dissociation, and total number of moles of particles before association or dissociation. For dissociation, alpha will be expressed as I minus 1 by n minus 1, whereas alpha is nothing but degree of dissociation, right? Degree of dissociation. And I is nothing but the number of particles actually present. Okay, number of particles actually present, and n is the number of particles expected. Okay, number of particles expected. Fine. For association, alpha is 1 minus I by 1 minus 1 by n. Okay, so let us work out some problems. The first one is, which of the following solutions will have the lowest and highest boiling and freezing points? So 5 solutions have been given: 0.1 molar sodium chloride solution, 0.1 molar glucose, 0.1 molar barium chloride, 0.1 molar KCl, and 0.1 molar aluminum nitrate. Now to find out, we need to understand the number of particles that upon dissociation these electrolytes will give. Okay, now 0.1 molar sodium chloride will provide 2 into 0.1 into Avogadro number of particles, because it will dissociate as sodium ion and chloride ion. Glucose, being a non-electrolyte, will give you only one particle, and that's why 0.1 into Avogadro number of particles. And barium chloride, being ionic, will give you 3 particles, barium ion and 2 chloride ions. So 3 into 0.1 into Avogadro number of particles. Again, potassium chloride will provide 2 into 0.1 into Avogadro number of particles, and aluminum nitrate will provide 4 particles, 4 into 0.1 into Avogadro number of particles. So obviously from the above findings, 0.1 molar aluminum nitrate has greater number of particles, therefore it will have highest boiling point and lowest freezing point, whereas 0.1 molar glucose solution, this will provide a lesser number of particles in the solution, and that's why it will have lowest boiling point and highest freezing point. Okay. Now the second question: 0.01 molar aqueous solution of K3FeCN6 freezes at minus 0.062 degrees Celsius. What is the apparent percentage of dissociation? K for what is given 1.86 Kelvin kilogram per mole. Okay. From the data, I can write like delta TF is equal to minus 0.062. Sorry, or it can also be expressed in terms of Kelvin. And KF has been given, which is nothing but 1.86 Kelvin kilogram per mole. Okay, and the molality has been given, it is nothing but 0.01 molar. So I am going to find out I. Okay, and I know that delta TF is equal to I into KF into molality. So upon rearrangement, I can also be written as delta TF by KF into molality. Substituting the values, 0.062 Kelvin by 1.86 Kelvin kilogram per mole into 0.01 mole per kilogram. Right? Now they will get cancelled. Fine. Mole. I'm sorry. Right. Kelvin will get cancelled. So I'll get 3.33. That's the answer. So this is the value of I. Now for dissociation, I know that alpha is equal to I minus 1 by n minus 1. Okay, so 3.33 is the I value, minus 1 by number of particles expected will be 4 because K3 FeCN6 will dissociate into 3 potassium ions and FeCN6 3 minus ion. Okay, so totally 4 ions, so 4 minus 1, which will give me 0.7767 or 77.67%. Fine. So phenol associates in benzene to a certain extent to form dimer. A solution containing 2.0 into 10 to the power minus 2 kg of phenol in 1 kg of benzene has its freezing point decreased by 0.69 Kelvin. Calculate the degree of association of phenol. So Kf for benzene is 5.12 Kelvin kilogram per mole. Okay. Now I know that delta Tf is 0.69 Kelvin and W2 has been given, it is 2.0 into 10 to the power minus 2 kilogram, or that is nothing but 20 grams. Fine. And M2 I have calculated, which is nothing but 94 gram per mole, and W1 has been given, it is 1 kg. Right. Now I know delta Tf is equal to I into Kf into molality. Upon rearrangement, I is equal to delta Tf by Kf into molality. Now molality is nothing but W2 by M2 into 1000 by W1, right? Now this value is nothing but 1 kg, it is given, so I need to put W2 by M2 only. So I can rearrange the formula like delta Tf by Kf into W2 by M2, right? So I am going to substitute the values. Fine. 0.69 Kelvin into 94 gram per mole divided by 5.12 Kelvin kilogram per mole into 1 kg, right? So this mole per mole will get cancelled, Kelvin will get cancelled, and when you simplify this you will get 0.633, and this is your I value. Now to calculate dissociation, okay, to calculate alpha for dissociation, I know that alpha is equal to 1 minus I by 1 by 1 minus 1 by n, okay, because it is association, no? It is association, right? So 1 minus 0.63 divided by 1 minus 1 by 2, because it will undergo dimerization. So I will get 0.27 divided by half. So upon rearrangement and calculation, we will get a 54%. I will get 0.54, and when I multiply this with 100, I can convert it into percentage. So the degree of association is 54%. Fourth one, what will be the degree of association of what will be the degree of dissociation of 0.1 molar magnesium nitrate solution if Van't Hoff factor is 2.74%? This is very simple. I am going to calculate what is alpha. Alpha is I minus 1 by n minus 1, right? So it is given that I is 2.74 and minus 1. Since magnesium nitrate is given, magnesium nitrate will dissociate into 3 particles, so it is 3 minus 1, which will get me 1.74 by 2, that is nothing but 87%, which means answer B is right. Now the last question. A solution X, when dissolved in a solvent, associates to form a tetramer. Then value of Van't Hoff factor for the solute is. Now it is given the solute X will associate to form a tetramer. So it is association. So alpha is equal to 1 minus I by 1 minus 1 by n, which means alpha. I am going to take alpha as 1. Okay, so it is nothing but 1 minus I by 1 minus 1 by 4, right? 1 by 4 means number of particles. So now which means it is 1 minus I by 3 by 4, right? 3 by 4. Now which is nothing but 4 minus 4I by 3, and upon cross multiplication 3 is equal to 4 minus 4I. So I is equal to 1 by 4. That is nothing but 0.25. Okay. So 0.25 means answer B is the right answer. Thank you guys.